Hello.
Okay, right. Uh, we now look at some technique how to differentiate. Now, what we have been doing so far, A, B, C, D, they are just simple differentiation. Doesn't involve any technique, manipulation, formulas, no, right? So now I'm going to show you two tricks. Now, let's say if we ask you to find the dy dx for y equals to 2x bracket x minus 3. Oh, you cannot differentiate straight away. So far, what you have learned is how to differentiate one term, one term, one term, term by term, like this. Like the d here, right? The d here. 3x squared, you differentiate, become 6x. Negative 5x, you differentiate, become negative 5. Positive 7, you differentiate, become 0. So you have differentiate one by one. Now, whenever it involves a bracket like this, you cannot differentiate. So what you have to do is you have to expand. So 2x multiplied by x, 2x squared. 2x multiplied by negative 3, 6x. Now, what we have been doing so far is just simplify. No differentiation yet. So if there's no differentiation, you cannot call it dy dx. Okay, now I perform the differentiation. 2x squared, bring down the 2. 2 multiplied by 2 is 4. 2 minus 1 becomes x to the power of 1. So 4x. Negative 6x differentiate, become negative 6. So this is the answer, this one, right? dy dx equal to 4x minus 6. This is the answer.
Why 2x2 become 4x?
After differentiation, originally there's a 2. You bring down the 2, then the x become to the power of 2 minus 1. So this is 4x. Okay or not? Originally there's a 2 there, so it's a 2. Then you have to bring down the 2 some more. So you bring down the 2. The second 2 here is from the power. The first 2 is from the original 2 here. This is the first 2. And the second
Oh,
is from the power. Then the power, after differentiate, you must less by 1. So 2 minus 1 is 1. X to the power 1, no need to write down. So it's 4x. They differentiate 6, negative 6x, become negative 6. This is the special case. Okay, next. Again, we have the bracket there. 2 bracket 2x plus 1 raised to the power of 2. So again, whenever you see the bracket there, don't differentiate straight away. Expand first. Expand, then differentiate.
mm.
So the 2 in front, you just leave it there. No need to do anything. Then this inside the bracket, you expand, become 4x squared plus 4x plus 1. So this is the quadratic, right? Then multiply the 2 inside. Because there's still a bracket there, you cannot differentiate. You have to do until there's no bracket, then you differentiate, right? So multiply inside, 8x squared, 8x plus 2. Okay. So until this step, you only expand, you didn't differentiate. So this function here is still called fx. After you differentiate this, then it is called f prime x. So 8x squared, when you differentiate, what you get? 8x squared.
16.
16, then the x less by 1 become 16x. Then this 8x become 8. Differentiate the 2 becomes 0. Okay, so
0.
this is the answer, right? This is the answer, 16x plus 8. Okay, one more example. Okay, here. Find the derived function for fx. Now this case, there's no bracket. There is a fraction, one denominator, numerator, and one denominator. But whenever you see this type, there's a fraction there with a line there, or there's a bracket there. You cannot differentiate one by one. Cannot. Only when you simplify until like this, until it looks like a polynomial, then you can differentiate one by one. This one, to simplify, you expand. This one, how to simplify? You have to cancel away the factor at the bottom. How to cancel away the factor at the bottom? You use this function here, right? You factorize the top. When you factorize the top, it becomes 2 brackets. One of the bracket can cancel with the bottom one. Okay? Can cancel with the bottom. So you are left with 2x minus 1. 2x minus 1. So far, as I've said, what you have been doing is simplifying the function. You have not differentiated yet. So this thing, 2x minus 1, is still known as fx. It is not f prime x. And now you differentiate 2x. Differentiate 2x, you get 2. Differentiate a number, you get 0. So the answer is f prime x equals to 2. F prime x is 2. Okay. Another example here, 3x squared minus 4x plus 5. They ask you to differentiate with respect to x. So you want to differentiate with respect to x, you must cancel away the x. How to cancel away the x? 3x squared divided by x. So 3x squared divided by x. Negative 4x divided by x. So negative 4x divided by x. Positive 5 divided by x. So you have positive 5 divided by x. Not differentiated yet. You are trying to simplify. So how to simplify? The x and x can cancel away. Then you have 3x. The x and x can cancel away. You have negative 4. This one cannot cancel away the x. This one is actually x to the power 1. You bring up is actually 5x to the power of negative 1.
Negative 1.
So far, still you haven't differentiated yet. You use up all your energy to simplify the function so that they become term by term like this. Term by term like this, you differentiate one by one. That is the only method you know how to differentiate. Differentiate 3x, 3. Differentiate negative 4, 0. Then this one, bring down the negative 1 minus 1 become negative 2. So this one is 3 Negative 5 you put at the top. This x to the power negative 2, you put x squared at the bottom. So this is the final answer. 3 minus 5 over x squared. Okay, so far what I've been showing you is if there is bracket, which is called multiplication, you have to open the bracket. You have to expand them like this. Like this, expand, or like this, expand. But if it is not bracket, if it is division, like this, 1 at the numerator, 1 at the denominator, you cannot differentiate one by one like that. Cannot. What you can do is you divide term by term. This divided by this divided by this divided by this. Until finally you have one term, one term, one term. You differentiate one by one. Now this one is different. This one is not x alone. It's x minus 1. That you have to factorize and cancel away the common factor. After you cancel away the common factor, then you differentiate one by one. So far, any
Okay.
question? Can follow or not?
No. Can follow.
Huh? Too
Can
fast.
follow.
Can
Can
follow.
follow.
Oh, can follow. Okay.
Mm.
So you remember this differentiate term by term. If you have this one, you have to change to negative power. You change to negative fraction, then you differentiate. But this thing you can follow is not good enough. You cannot reproduce in the exam. You have to practice some of these questions before you can show how to do it in the exam, right? Okay,
Mm.
never mind. I give you some. Oh, this one cannot. This one is the last part already. The last part of differentiation. Nearly the end of the chapter already. Never mind. This type, differentiate term by term. This one expand. This one divide. I will scan some questions and let you do, right? This one, just like I
Mm.
showed. Okay. So now, the more difficult differentiation. Now, the more difficult differentiation it involves many steps. It's not differentiate one by one, one by one, one by one. Like that. No more like that. So they involve 3 rules. The 3 rules, they are the chain rule, or they call it differentiate composite function. Second one, product rule, where you differentiate the product of 2 functions. Then the third one is the quotient rule. Quotient rule, you have to differentiate 2, one at the top, one at the bottom, where you cannot cancel. Cannot cancel. So you have to use the quotient rule. So these are the 3 rules for differentiation. Now, if it is just these 3 rules, then it's still easy. No? Sometimes the question will come when they combine chain rule with product rule, combine chain rule with the quotient rule, or those type of question more difficult, more difficult. So I start with the simplest one. Differentiate using the chain rule. What is this chain rule used for? Under what condition or what type of question we differentiate using the chain rule? What type of question? So the type of question that you use the chain rule is this type, where you have a bracket and the bracket is raised to the power of 4, raised to the power of -10, where if you want to expand the bracket, you have to use the binomial theorem. You still remember binomial theorem that we have learned in the first lesson? So you have to use binomial theorem, then you expand this. When you expand this power of 4, you have 5 terms. Then you differentiate one by one all the 5 terms. So we are not going to do that. There is a shortcut where you can differentiate straight away. Right? You can differentiate straight away. So if you see there is a bracket raised to a certain power, whether it is a positive power or negative power, you use the chain rule. Or what is the chain rule? I'm going to show you how to differentiate using the chain rule. Okay, so we copy down this function, 3 bracket 2x minus 1 raised to the power 4. 3 bracket 2x minus 1 raised to the power 4. You look at the part, the bracket where I have color them pink color, right? Okay. Now this number 3, no need to differentiate. You just copy down here. Then this purple color, or pink color, sorry, you bring down the power 4, like that. Then the 4 less by 1 become 3. Oh, because it's the chain rule, you have to differentiate what is inside the bracket. The bracket, you imagine the bracket no more. If there's no more bracket, what is inside the bracket is 2x minus 1. You have to differentiate one more time, 2x minus 1. Differentiate 2x, you have 2. Differentiate -1, you have 0. You have 0. Okay, right. So how to differentiate using the chain rule? First of all, you differentiate the bracket, the power of the bracket. Second step, you differentiate what is inside the bracket. What is inside? So you differentiate 2 times. When are you going to use this chain rule? You're going to use it when you see a bracket raised to a certain power. Where if you want to expand, you have to use binomial theorem. No need to use binomial theorem. The shortcut is differentiate the bracket, then differentiate what is inside the bracket. So 3 times 4 times 2, 24. So this 2x minus 1 become power of 3.
Mm.
Far okay or not?
Okay. Why
Okay.
the just now that one is just dy dx now become d dx only?
Because they didn't call it y. So they didn't call it y. I cannot simply call it y and say this is dy dx. So I say this is d dx of this thing. This thing is actually y lah. So it's actually dy dx. Sometimes you can look at it as differentiate with respect to x, this function. Differentiate with respect to x, this function. It means like that, right? Or if I call it y here, then this is dy dx. It will be very easy. But because they didn't say that it's called y, so I copy down the whole question again and tell them, differentiate this whole thing with respect to x. 3 ways of writing y, fx, and this way, 3 ways of writing the first derivative. Okay, so we're going to look at the second question. So how do you know this question? We are going to use the chain rule. How do we know we are going to use the chain rule? You look at it this way, right? You look at it this way. Because there is a bracket, and this bracket is raised to the power of 5. So I cannot do anything. If you want, you have to use binomial theorem. I don't use binomial theorem. Just differentiate straight away. How to differentiate? Differentiate the bracket. 5, you put in front. Then the power 5 less by 1. So it's 5x minus 1. Okay, so this is the first step. Second step, you have to differentiate what is inside the bracket. Differentiate inside the bracket, 3x squared become 6x. Negative x become negative 1. So this is the answer already. Cannot simplify anymore. Answer is 5 bracket 3x squared minus x raised to the power of 4. Then multiply with, this is multiply, don't add, not add, multiply with 6x minus 1. Differentiate 2 times. Chain rule. You think about it? Any question?
No.
No. Okay. No, then we look at the third
The
example.
the the
Yes.
cocoa color word is the binomial of the differential.
The purple color is the function that we are
The
going to
brown
differentiate.
color, brown color.
Brown color. Oh, this brown color comes from differentiating inside the bracket. I see brown color or inside the bracket one. I just want to show you different colors so that you know there are 2 differentiation. But if you already know, you have done many questions, then no need to this one, no need to show the color. Once you understand that, you know what to do, then okay. The purple color is differentiate the bracket. The brown color is differentiate what is inside the bracket. You have to go through these 2 differentiation in order to get the final answer. Okay? Okay, so we look at the third example. Now I call it y. So if I call it y, the answer will be dy dx lah. If I call it fx, the answer will be f prime x lah. So this one, I have to differentiate. Now you remember earlier on, if it is at the bottom you cannot differentiate one. You have to bring it to the top first. You have to bring it to the top, then only you can differentiate. Another example like that. You see, this x to the power 5 is at the bottom, cannot differentiate. So what you need to do is, this thing at the bottom, you have to change it. Now, the changing part is, you have to be very careful. You see, this is 4/3, So 4/3, outside is 4/3. This 3 doesn't belong to the bracket. So when you bring the thing to the top, the 3 doesn't go to the top. The 3 is a number. It remains at the bottom. See that? 4/3, 4/3, 4/3. 3 doesn't follow the function go up. This function will go up. 1 minus 2x to the power of 3, it will go up. It becomes 1 minus 2x to the power of negative 3. When you go up, power is negative. Now, I have something bracket raised to a certain power. So straight away, I see bracket raised to a certain power. This must be composite function. This must be using the chain rule. So using chain rule, 4/3 don't do anything. 4/3 just leave it there. Differentiate the bracket, negative 3. Negative 3, then negative 3 less by 1. Negative 3 less by 1. Then I differentiate what is inside the bracket. Differentiate 1 becomes 0. Differentiate negative 2x become negative 2. Okay, no? Differentiate the bracket, negative 3, negative by 3 minus 1. Differentiate inside the bracket, negative 2. 2 steps. Differentiate 2 times. Then I gather all the numbers together. Negative 3 and 3 can cancel. Negative and negative 2 become positive 2. Positive 2 multiplied by 4 become 8. So the answer is 8 bracket 1 minus 2x to the power of negative 4. Negative 4, you bring it to the bottom. So it becomes 1 minus x to the power 4. 8 over 1 minus x to the power of 4. Any question?
No.
Hmm?
No.
No question. No question, then we look at one more. Square root one. Square root, again, you cannot differentiate straight away. You have to change the square root to power of half. Square root is power half. If the power half is at the bottom, you bring it to the top, it's negative x to the power half. Okay, so it's power half, but no negative because it's at the top. So differentiate the bracket. Half bring to the front, half minus 1. Half bring to the front, half minus 1. Then differentiate what is inside the bracket. Differentiate inside the bracket become 2x. This one become 3. This one becomes 0. This one becomes 0. Okay? So it's 2x minus 3 only. And when 2 negative, half minus 1 is negative half. This one power negative. So this thing will go at the bottom. This one power positive. So this one will go to the top. Number, this number go to the bottom. This number go to the top. So finally you have 2x plus 3 multiplied with 1. So it's 2x plus 3. 2 multiplied with this thing is 2 multiplied with the square root of 2x squared plus 3x plus 1. You have to do slowly, slowly. So we finish the chain rule. So to finish this chapter, you have 2 more rules, that product rule and quotient rule, and also combination of the rules. Combine the rules. Use the rule, 2 rules at one time. That is the final part. So for the chain rule or composite function, this is the question. These are the questions that you need to do. So maybe you can screenshot this thing. Okay. Number 3, no need to do. Number 3, no need to do. You just do number 1 and number 2. Okay or not?
Okay.
Okay. This one is a lot already. In school, we finish this in 3-4 lessons. Okay, next one will be the product rule.
I got one question. The just now that part. The can do one simple one. How the brown color words came out. The brown color numbers come out.
Okay. Brown color is you differentiate inside. Differentiate x squared become the power 2 bring in front become 2. X less by 1 become x. That's why you have 2x. Differentiate 3x, no need to think. Straight away answer 3 because it's the special case. Differentiate 1, no need to think, 0. That's why no need to write. Right? So you have this. This one is positive, so it's at the top. This one negative, so it goes to the bottom.